What is quality management and what purpose does it serve? Quality management is there to ensure that a project will satisfy the established needs that were created when the project was undertaken, and the customer needs, as the customer ultimately decides the quality of the product.
The importance of quality management is to ensure execution of quality among the scope, time, and cost to provide excellent outputs, products, services, customer satisfaction, growth, and performance. Therefore, it's a duty of the project management to fix and meet the stakeholder needs and expectations.
Project quality management involves three main processes. Planning quality management includes identifying which quality requirements and standards are relevant to the project and how to satisfy them. Incorporating quality standards into project design is a key part of quality planning. For an IT project, quality standards might include allowing for system growth, planning a reasonable response time for a system, or ensuring that systems produce consistent and accurate information. Quality standards can also apply to IT services. You can set standards for how long it might take to get a reply from a help desk or how long it might take to ship a replacement part for a hardware item under warranty. The main outputs of planning quality management are a quality management plan, a process improvement plan, quality metrics, quality checklists, and project documents updates. A metric is a standard of measurements, and metrics are often used to assess quality. Performing quality assurance involves periodically evaluating overall project performance to ensure that the project will satisfy the relevant quality standards. The quality assurance process involves taking responsibility for quality throughout the project's life cycle. Top management must take the lead in emphasizing the roles all employees play in quality assurance, especially senior management roles. The main outputs of this process are change requests, project management plan updates, project documents updates, and organizational process asset updates. Controlling quality involves monitoring specific project results to ensure that they comply with the relevant quality standards while identifying ways to improve overall quality. This process is often associated with the technical tools and techniques of quality management, such as Pareto charts, quality control charts, and statistical sampling. The main outputs of quality control include quality control measurements, validated changes, validated deliverables, work performance information, change requests, project management plan updates, project document updates, and organizational process asset updates.
Project quality is affected by changes in scope, cost, and time. Changes in the scope of the project can limit functionality. These changes may prevent proper testing from taking place due to time or budget constraints. This is known as scope creep, which adds to the initial core goal of the project. Changes in cost lead to budget cuts, which in turn allows less funding to hire qualified employees or retrieve the best possible resources. Time constraints lead to a rushed project timeline. This does not allow time to review work, which makes the product susceptible to defects. Cutting corners also leads to lower quality as it generates a product that is not made as initially intended.
There are many tools that assist with performing quality management. Cause and effect diagrams are one example. Cause and effect diagrams help project managers trace quality problems back to their source. They assist in finding the root of the quality problem. These diagrams are also referred to as fishbone and Ishikawa diagrams. Control charts are another helpful tool. They display data and show if it is in or out of control. The control chart makes a control line where you want your data to be similar to. When data points are under your desired level, then there is a quality problem that needs to be fixed. Check sheets are also used to perform quality management. These are very similar to tally sheets. Data is entered with data and shows a total of tallies for each group. These can be very useful for finding where your quality problems are. Scatter diagrams are diagrams that display points on a graph and easily show outlier points. This also helps with finding quality errors. Histograms are a form of bar graph. They display how groups of data stack up against each other. These help visualize groups of data and how they compare. You can analyze quality data and make inferences using this tool. A Pareto chart is a form of histogram that helps point out the main points of quality issues. It looks very similar to a histogram, but adds another line to show where data is failing. Flowcharts are the last of the main tool of performing quality management. These graphical displays show the logic between data. They show where data is having issues and helps point the problem areas back to the source. As you probably noticed, all of these graphical displays show different ways of finding quality issues, which are very helpful for project managers.
In quality management, there are multiple types of tests that can be performed in order to ensure quality. Unit testing is where you test an individual function or feature to make sure that it works. Integration testing is where you test a combination of those functions and features to make sure that they work together. System testing is where you test the completed product as a whole. And user acceptance testing is where you provide the completed product to a select group of users who will deem whether or not features and functions of the product are acceptable for use, and if they are not, then the product will have to undergo retesting.
So to finish out this presentation, we are going to review a case study. The case study will look at spacecraft electronics components. This is a good process to look at for quality management because quality is crucial in this production process. Once a rocket or spacecraft of any kind takes off, it's very challenging and costly to try to make repairs to it, and obviously you want to have a successful launch as well. So getting the parts, the electronic components correct, making sure they're of good quality is crucial. The citation for this case study is posted at the bottom. You can Google that and find it. It's on the PMI website. So going forward, we are going to look at the 3 stages of quality management in this given context. And that includes quality planning, quality assurance, and quality control. Quality planning is the first step in quality management, so that's where we'll begin with this case study. In spacecraft electronic component manufacturing, there are strict pre-production standards that are set to guide the process and make sure that the highest quality parts are being produced so that there are no failures. So this includes requirements for inspection, documentation, and feedback of data, and what that means is they're looking at the acceptable levels, the acceptable data points that they want to see when they're doing assessments on the quality of the products. There's actually a 100% inspection of all electronic boards. This harps back to those strict standards. And the typical outputs of quality planning in this manufacturing process are a clear outline of how things are going to be done with the quality management process. So a clear plan, operational definitions, and an item checklist. Next, we will look at quality assurance, and quality assurance is the collection of data to make sure that the manufacturing process is on the right track and to instill confidence that the requirements for these electronic components will be met. So what is done in quality assurance of this manufacturing process is discrepancy reports are created. So this is a record of defects that's placed in a database. What this database looks for, what data it collects is where the defect occurred, when it occurred, who noticed that it occurred. It also collects the circuit board number, which is essentially like a circuit board ID. It helps to identify which particular circuit board this defect was found on, and then the type of defect that is seen on this electronic component. The output that comes from quality assurance in this manufacturing process is an increase in effectiveness and efficiency. The last piece of quality management that we will touch on in regards to this case is quality control. Quality control is essentially analyzing data to make sure that the product meets requirements. If requirements are not being met, then a corrective course of action will be suggested. In this particular case, they break down the overall defects by type of defect, and they do a Pareto analysis to see which types of defect contribute most to the overall defect, so they can hone in on those specific type of defects when they look at the manufacturing process. They also look at the relationship between the number of inspections being done each week and the number of defects each week. While the number of defects each week can vary simply because of what's going on with the manufacturing process, it can also vary because of how many electronic boards were inspected on that particular week. It can be assumed that if you are inspecting less electronic boards, you're also going to have less defects in most cases. So it was important to also look at that when they were doing their analysis of the data. As I previously touched on, some of the outputs of quality control are those process adjustments and rework of the product, and also complete checklists. So this slide is a continuation of the previous quality control slide. It includes visuals that hopefully enhance your understanding of the material that was presented on that last slide. So on the left, there's a pie chart, and on the right is a Pareto diagram. And what both of these charts do is they help to give you an idea of where the defects on the manufacturing line are concentrated so that you can begin to plan out where your corrective courses of action will be focused to enhance the process and hopefully meet product requirements. So while they do achieve the same task, they do it in a different way in how the data is visualized. So some minds might like to see it as a Pareto diagram and others might like to see it as a pie chart. So this is actually our final slide. Thank you for listening. We hope it was informative and interesting. If you're interested in learning more about quality management and just project management in general, PMI is a great resource. That is where this case came from. And besides cases, there's a ton of other information on project management that would prove helpful. Thank you again.